I now want to take a look at this part of the concept map. Before we begin, let's just take a look at the basic concept here, is that if the stimulus is a decrease in blood pressure, we can increase blood pressure by increasing blood volume. So an increase in blood volume increases blood pressure. Noting that this decrease in blood pressure could have in fact be caused by a decrease in blood volume such as hemorrhage. Taking a look at the concept map, we can see that if we have a decrease in blood pressure right here, what we have done is increased blood volume. If we increase blood volume, we will then increase blood pressure. So let's take a look at the actual mechanisms that are going on in this part of the concept map. Before we start our discussion, I just want to quickly talk about something that we will be looking at in more detail when we get to the renal section. But what I'm looking at right now is this little bit right here. We have to look at the exchange of fluid and ions, such as sodium, electrolytes, between the kidney and the blood. What happens is, during the process of urine formation, okay, water and fluids and electrolytes are going to be exchanged between the kidney and the blood. What I specifically want to talk about right now is the movement of sodium going from the kidney back into the blood. This movement from kidney to blood is called reabsorption. So we can have the reabsorption of sodium back into the blood, and this is going to lead to water following. Okay, so now we're going to have an increased reabsorption of water. What I want to appreciate here is the overall effect. If we increase the movement of water from the kidneys back into the blood, what we are going to do is increase blood volume, and what that results in is an increase in blood pressure. So, if you increase reabsorption of water, you are going to increase blood pressure. We're going to look at two mechanisms now that actually do this. One is via the RAAS system, and that is this system right here, and then we're also going to look at antidiuretic hormone. I want to examine what is known as the RAAS system. The R stands for renin. There it is right there. The A stands for angiotensin, which is right here. The other A stands for aldosterone, right there. Noting that the overall response of the RAAS system is to increase the reabsorption of water from the kidney into the blood, okay, increasing blood volume, and therefore increasing blood pressure. So on the next slide, we'll take a closer look at this RAAS system. The receptor responsible for triggering this response, the RAAS response, is baroreceptors found in the kidney itself. So these baroreceptors are in addition to those that we've previously looked at in the aortic arch and in the carotid sinus. So these baroreceptors are going to respond by stimulating the release of renin. Okay, so that is the R in the RAAS. Renin, through a bit of a complicated response, which we'll look at in more detail when we do the renal system, triggers an increase in the amount of angiotensin II in the blood. That is the second A in the RAAS. So you increase renin in response to a decreased blood pressure, and that angiotensin II then does a couple of things. Let's just look at its response as indicated by this line right here, which is a little bit hard to see. It is going to go to the adrenal cortex. It then stimulates the adrenal cortex to release the hormone aldosterone, and that is the final A in the RAAS. So renin, angiotensin II, aldosterone. Aldosterone then goes to the kidneys and increases the reabsorption of sodium, and thus the reabsorption of water, and as previously discussed, that is going to increase blood volume. That increase in blood volume will then increase blood pressure, which again is the correct homeostatic response If the stimulus was a decrease in blood pressure, the response is going to be an increase in blood pressure. Angiotensin II not only affects blood volume by altering levels of aldosterone, it also causes vasoconstriction. So angiotensin II, as we'll see, actually has quite a few different roles, but it increases blood volume by increasing water reabsorption. It also increases systemic vascular resistance by causing vasoconstriction. So both the increase in blood volume and the increase in systemic vascular resistance is going to increase the blood pressure. The other hormone involved in this response is ADH, antidiuretic hormone. It also increases reabsorption of water from the kidney back into the blood, and as a result is going to increase blood volume and increase blood pressure. If we take a closer look at this, we can see that ADH is being released from the posterior pituitary in response to the hypothalamus. What is stimulating the hypothalamus is the signals coming in from the same baroreceptors that we've looked at before in the carotid sinus and in the aortic arch. The ADH then goes to the kidneys, and I kind of ran out of room here, but ADH shows up again right here. So ADH goes via the blood to the kidneys and increases the reabsorption of water. And as I've indicated here, if you increase water, you increase blood volume right there, and as a result, you increase blood pressure. So in summary, once again, in response to a decrease in blood pressure detected by baroreceptors in the carotid sinus, in the aortic arch, and also in the kidney itself, we are going to have the overall result of an increase in blood volume, which increases the blood pressure. There are a few components to this. We have ADH being released from the posterior pituitary, which increases the reabsorption of water and therefore increases blood volume. That is in response to the hypothalamus being stimulated from the afferent signals coming from the carotid sinus and the aorta. We then have the RAAS system, and it is responding to the baroreceptors in the kidney, sending out renin, angiotensin II, stimulating the release of aldosterone from the adrenal cortex, which again increases the reabsorption of water and increases blood volume. Remembering that angiotensin II also causes vasoconstriction, and as a result is going to increase this, the vascular resistance and increasing blood pressure that way also.